Hey guys, we're here for lesson 25 in module 5, and that is a lesson that we should move through really quickly because it's something we've talked a lot about up until this point. It's about identifying those whole number fractions. So if you're working in halves, for example, and you have two wholes, you'd say that you have 4 halves, and that's something that we've done a ton of up until this point. So this should come pretty naturally to us at this point. But let's go through the problem set and take a look at how to do a couple of examples. So you'll see here on the first one, like it's showing you that like when you have something that size, that's one whole. All right, so this is all going to be represented in pictures. We've done more advanced work than this already. We've already talked about this on a number line. So again, this should be just a good way to review. And so if this whole is split up into 3 pieces, you'd say that's 3/3. Right, 3/3 equals 1 whole. Okay. You could take that same whole and you could split it into 2 parts. So now we're working in halves. And so in this thing, we have to look at, I'm working in halves. So my denominator is 2. My denominator is how many parts are there in one whole? There's only 2 parts in this whole. So my bottom number is going to be 2. Now the top part is like how many are shaded in? There's 1, 2, 3. 3 halves have been shaded in. So this is 3 halves. We can move over to this next one. We haven't done one like this, I don't think. This one is interesting because each whole is only in one part. And so when that's the case, when each whole is only in one part, then the bottom number is actually 1. Right? And then we have the top number being how many ones do I have? How many 1 wholes do I have? I have 1, 2, 3. I have 3 1 wholes. So, or 3 wholes altogether. Okay, let's move on and try the next one. Okay, well, 1 whole, again, that's the same size as that. 1 whole is made up out of 4 shaded pieces out of 4 total pieces, or 4/4. Okay, simple enough. Let's move over to this. Now we have that same whole, except this time it's been split into, each whole has been split into 2 pieces. The trick here is not to say that this has been split up into 4 pieces, right? Like, because you can see 1, 2, 3, 4. You're like, oh, look, it's split into 4 parts. But that's not true because each whole has to be looked at individually. How many parts has each whole been split into? And in this case, it's 2. Now, when you count the top, the numerator, the top part, that's when you say how many parts altogether have been shaded in. And that is actually 4. So 4 halves equals 2 wholes. This last one, again, it's the same one as the one we did up here, same concept at least, where the bottom number, the denominator, is 1. And the bottom number is 1 because none of these have been broken up into different parts. There's 4 wholes, and they've all remained whole without being split into parts. So it's 4/1, and when we see that, we know the total is 4. It's like saying 4 individual wholes equals 4. And this is it, believe it or not, this bottom part. There's no back to this page for our problem set today. So the first one is 1, 2, 3, 4, 5, 6. We have 6 things shaded in, and the whole shape only has 6 parts. So 6/6 equals 1 whole. Anytime that numerator, again, we've talked about this a number of times, and you've heard me say it a bunch, but anytime the numerator and denominator are the same number, it's 1. It always equals 1. So here we have 1, 2, 3. My bottom number is 3. Notice, to figure out the bottom number, I only have to count how many parts are in one of my wholes. And then the top number is how many parts do I have altogether? 1, 2, 3, 4, 5, 6. I have 6 shaded in parts. 6 out of 3, and you can see that equals 2 wholes. I've filled in 2 entire rectangles here. Right? You also could think of that as 2 times 3 equals 6. 2 wholes times 3 parts per whole equals 6 total parts. You could think of it this way too, like 1 whole times 6 parts equals 6 shaded in parts. 1 times 6 is 6. 2 times 3 is 6. Right? Over here we have 1, 2, 3, 4, 5, 6. We have 6 things shaded in, And each of them is one whole all by itself. It hasn't been broken up into any other parts. So let's take that a little step further, since we've done some more advanced work than is being asked of us here on this page. And I'm going to draw a number line from 0 to 2. And I'm going to break it into thirds. So I'm going to break both holes into thirds. I broke my 0 to 1 into thirds. See, 1, 2, 3. And my 1 to 2, that hole, I broke that into 1, 2, 3. And the picture of this would look like, if I was doing the same pictures as the front, I'd have 2 holes here, and they're both broken up into thirds. So like this hole goes over here, that hole goes over there. Now, if I said I want to find the fraction 6 thirds, let's go 1, 2, 3, 4, 5, 6. That's 6 thirds. Where does 6 thirds go on my number line? Well, I broke them all up into thirds, and now I need to count 6 of them. So 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6. Oh, not 6, 6, 6 thirds. Whoops. I led you down the wrong path there. 6 thirds. So that's 0 thirds, 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds. So even your teacher gets confused about this stuff sometimes. 6 thirds, because there's 6 things filled in, or 6 spaces taken up in this case on the number line, and each space represents 1 third. Like that's 1 third, that's 1 third, 1 third, 1 third, 1 third, and 1 third. And there's 6 of them all together to get to 2. And you also can do whole number times denominator equals numerator. We've talked a lot about that. So 2 wholes times 3 parts per whole equals 6 parts. All right, so we can figure out the numerator that way too, if we didn't, say we didn't know it, for example. And so that's where, again, that's work that we've done. We've covered this for a number of lessons, but it does go along with that same stuff that we're doing on the front side of that problem set there. So this was a good review. It's a good way to get back to basics and really look at those visuals. But it also goes right along with the work that we've been doing on number lines as well. So, all right, guys, keep up the hard work. You're doing great.